Hey everybody, thank you so much for coming out. I'm pretty stoked about this talk. Hold on. Got to turn this thing on. There we go. My name is Wes Boss. I'm a full stack dev from Hamilton, Canada. I'm at Wes Boss on Blue Sky. That's it. Anyone else on Blue Sky yet? Any losers don't have invites yet? Oh boy. I make web development courses, as well as I have a podcast called Syntax. Anybody here listen to Syntax once or twice? Yeah. So this talk today here is about server-side JavaScript. It's specifically about the different JavaScript runtimes. And what a runtime is you take your engine, which runs the JavaScript, and then you take your APIs for things that us web developers use to actually interact with the runtime. So that's what a runtime is. There's kind of three main engines out there right now. There's several others, but these are the big ones. You got V8, that's the one that runs in Chrome and Edge and Chromium and therefore runs in a lot of other places. You got SpiderMonkey, which runs on Firefox, and then you have JavaScript Core, which runs on Safari as well as the PlayStation browser and several other ones out there, right? Those are our three main engines out there. So we have Node on the server. We have Node that runs on V8, right? Now we have Deno, which also runs on V8, and that's Deno deploy, Netlify edge functions, Supabase edge functions, a whole bunch of the other ones. Now we have Cloudflare workers that actually also runs on V8. That's what Vercel edge functions are running on as well. We have Bun, which took the JavaScript core, the Safari engine, and they're making a new server-side runtime as well. There's Fastly Compute, which runs on SpiderMonkey. There's Alibaba Edge Compute, which runs on V8. And those are just the ones that you can sign up for. There's also things like the folks from TikTok and Bloomberg are also working on some cool stuff as well that are running V8 projects. So if my math is correct, we have like 3 browsers to sort of target, but we have 6 server-side runtimes that we could possibly be targeting, which is wild to think that JavaScript there's more environments now on the server than there are in the browser. So you might be thinking like, oh my goodness, are we going to have IE 6 of the server at some point? Like, is this not... Can't we just stay with one and stop changing things and it just will run in one place? So the question we have now is like, why do we have all of these different runtimes? Weren't we fine with just having Node? So the ideas behind this is that it's better. We have things like TypeScript support right out of the box. You don't need to compile it or transpile it and do all these weird module things. There's a major push for having standard APIs, which is what this whole talk is about here. They're all to the ESM spec. They have things like being able to import from a URL with a module. And then there's just like a lot of like easy wins. Like, you know, when you're building a Node app and you're like, oh gosh, I gotta install the .env plugin. And you know, like there's like 8 things you need to do before you get up and running in Node. At least for me, I write a lot of little scripts, a lot of little packages, and it's really nice to have an environment where like you can just start writing code and it just, all that sort of setup is left behind. It's really just a joy to work with. Faster. So I'm not gonna stand here to spout numbers at you and whatnot. Honestly, that's not really my forte, but you're going to hear things like cold starts and Rust and WASM and asynchronous, non-blocking. You're going to hear a lot of these things being thrown around to say that these environments are faster, and we'll look at why that is and what the limitations of those are. And then like stronger as well. Like, so Deno was built by Ryan Dahl, creator of Node.js. And from the get-go, Deno says, okay, you get access to nothing, kind of like your Mac, right? You have to approve every single thing in there, and it will tell you anytime you want to access the network or be able to write to a file or read to a file on your local network, and you can give it access to a specific thing, which is probably a good thing when we're all NPXing these random scripts from random dudes on the internet and be able to run them on our computer. So let's talk about the different server kinds. We have 3 kinds. We have the traditional long-running VM with the server. So this is you go get like a DigitalOcean box and you type node index.js and you're running your server until it falls over or you stop it, right? They're always running. They maintain memory entirely in the application. To scale up one of these things, you give it more memory or more CPU, or you do more servers and you just load balance them based on the traffic coming in. Then, a couple years ago, we got serverless functions, which everybody loves to talk about how there's still servers. They only run in short bursts when needed. So somebody hits a specific serverless function, it starts up, it runs the code. To scale a serverless function is it just runs more of those functions if it needs to. And you really just pay for what you need. So you're not necessarily running a server for something that gets hit once a month or every so often. Now we have this thing called the edge, which sounds really cool. And they say we have edge functions. So like, what's the difference between serverless function and edge functions? Is they're pretty close to each other. Edge functions generally run closer to your user, so they're distributed to different data centers around the world. They can run in between your requests. This is a really good use case I'll talk about. They have a limited API, so they don't have the full-blown node compatibility, although that is starting to change as well. And then they generally bill you based on what's called CPU time versus wall time, meaning that CPU time is, let's say you loop over an array of 6 things, and then you make 6 network requests. You're only paying for like the loop over and then the start of the network request, and then when you're sitting there waiting for the request to come back, you're not paying for that time to run until it comes back, and then you work with the JSON data or whatever that comes back. So like, what are we supposed to do with all these different runtimes? Are we supposed to support all of them? And the answer to that is kinda, yeah. But the answer is JavaScript, right? JavaScript is how we're going to support all of these things. So we have 3 major standards bodies right now. We have TC39, they're responsible for like the actual language itself, async await, const, ECMAScript modules. And then you have W3C, their WebRTC, and the Streams API, and web components, and then the WhatWG, they're responsible for fetch and other properties like that. Now, how many of you have installed this thing in the past, right? Probably everybody in this world has installed it this morning already, right? 45 million within a week. And like, why do we have node fetch or isomorphic fetch as a package when shouldn't it be built into the language? And the answer to that is that fetch was like a browser API. And the reason we didn't have it in the server is because it was a browser API, right? So there's a new community group called the Winter CG, which is built up of all of those companies that I just showed in the earlier slide. And their idea is to make sure that we have standards that this JavaScript is going to run on all the environments, and we're not using specific APIs for every single runtime. So browser.js is server.js. We don't need different ways to do the exact same thing. And that's sort of the whole point of this talk, is that code you write in the browser will also be code that you can run on the server. So let's take a look. Probably the biggest one is the fetch API, in that requests and responses are live, both on the server and on the client. So when you have the browser, you make a request, you use the fetch API, right? And what you're really doing there is you are creating a request, and you're getting back a response from the server. And on the server, it's the exact same thing. When you get a request coming in, if you've used Express or whatever in the past, that's not a web request or a web response. That's a custom node thing. However, if you've written a serverless function or anything like that, you may have noticed that this pattern kind of looks the same across all of these different servers, and that's because they're all based on the fetch standard. So I took this function that we have right here, and if you want to run it on Deno, it's the first one, and the second one we're running it on a Bun server, and the third one we're running it on Cloudflare. The fact that that handler can intercept or have a request come in and work anywhere is actually pretty cool. It's not native in Node yet. However, there are lots of plugins, Hano.js, Fastify plugin. You probably have used it before in Next.js routes or SvelteKit or Astro or anything like that, is that this is the standard. And this is what allows all of these JavaScript frameworks to be deployed to anywhere, right? The next one is web streams. You basically can chunk your data as it's coming in. So streams are the ability of your server to send data to anywhere, really, probably the client, from the server to the client before the server's even done. So if you're rendering your React application, and your React app says, well, I'm not done yet, but I've got the header, or I've got like parts of it, you can send that data to the client. You can set up the request. You can do all the headers, the handshaking, all of that stuff. And while the server is still rendering out your application, the browser can actually have a bit of data as you're going in. That's really cool that when you're using web streams on the client, you can make an abort controller to cancel the specific request. And then on the server, you can simply just run a cancel method in your readable stream. And there's no libraries, there's no extra if statements, there's no code. On top of that, by just using web streams, the client and the browser can talk to each other without having to have some sort of intermediary layer. If you have rendered streams in a React application before, you notice, I don't know if you've used this, but a lot of frameworks use this under the hood, right? And in order to make it work on all of these environments, we just use render to readable stream. Why? Because that is a web standard, and it will work literally everywhere. It will actually, Node.js has their own streams, but they also have web streams now, right? They support it natively, and they have a really nice compatibility layer if you have a Node stream and you want to convert it to a web stream, which is great because, again, browser code, client code, server code is the same thing. Events. This is actually kind of a really interesting one when I first saw it, is that events work anywhere. Like, if you take a look at this code right here, add event listener, you might think, oh, that's a vanilla JavaScript API. But in reality, if you run this in the browser, it will work. If you run it on the server, it will work as well. So the same syntax, and in some cases, the same events, will run on the browser and in the client. You can make your own custom, so they all extend event target. So if you want to say, all right, my application is interested when a user is updated, or like I took an Uber here from the thing, and after the Uber was done, it popped up a little thing that said, hey, do you want to book your flight home, or do you want to book your car home? And I thought, oh, that's cool. They're probably firing some sort of event like ride over, and then there's somebody else in the application listening for ride over, and when that happens, you can do things like throw a pop-up or log some data or whatever it is that you want. The form data API. So how many of you are using Remix in here? Not a, oh, yeah, pretty good. So the form data API is actually pretty cool because, again, it was a browser-based API for being able to collect data and set it in this specific object. And you can pass your form data to the body of a fetch function. Well, that code will work just as well on the server side. It's a great way to be able to architect your data before sending off a request. Web workers. Web workers allow you to do multi-threaded. That's always the thing. Everyone says, well, JavaScript's not multi-threaded, but you can make it multi-threaded if you throw it into a web worker, and you can have stuff running actually in parallel, not just concurrently like async await. That's great for CPU-intensive tasks. It's non-blocking. Service workers-ish. I put ish on there because it's not actually supported, but the whole Cloudflare worker runtime is based on the service worker API, and it's really nice for intercepting requests. So right here, what I have is I just have a handler. There's that request that comes in that we talked about earlier. What you can do is you can fetch another website, get the HTML back. You could, in this case, I'm just waiting for it all, but you could stream it as well, like we were talking about. You replace a specific word on the page, and then you simply just return it out the other way. And this is an extremely popular use case for edge functions because you can write code that sits in between the request in the actual end server. So even if you are using any server, could be a Rails app, you can still put a little bit of JavaScript in between that request and be able to intercept it and grab it. And that's good for A/B testing or country-specific stuff, or if you want to be able to add some specific logic to a request without actually going into the application code base. You can write a little bit of code that sort of sits in between. So why is this useful? Well, proxying. At the very least, you can take one of those event handlers that I was showing and write a one-liner, return fetch reactathon.com. And what that will do is it will literally just proxy the entire website for you. So if something is blocked at your work and you can't get onto it, you could write a 3-line proxy to proxy the entire website through a different domain name on the server side. Back to the proxy. Another cool example that I did was I use Cloudinary. Anyone use Cloudinary here? To process and resize your images and whatnot, and I love it, but it's kind of expensive once you get past the free plan. So I wrote a Cloudflare worker that sits in front of Cloudinary and said, when somebody requests an image, if it doesn't exist, then just pass it along to Cloudinary and they'll resize it and whatever. But if it does exist, then just cache it, and you can just cache it on Cloudflare, or cache it on your own CDN. So you get all the benefits of the SaaS, but then you can just cache it in your own little CDN, and you're not paying for the overhead. I'm sure they don't like me telling you that, but it's kind of cool. I open sourced it on GitHub. Add custom CSS to a SaaS. So I have this Cloud App screenshot tool, and it doesn't look very good, and they removed some functionality that I really liked. So I said, well, screw you guys. I'm going to add that functionality back. So I just put a Cloudflare worker in between, and this could be an any edge function. I put it in between the SaaS and my domain name, because I had a custom domain name. And what it does is it intercepted the request. It went and got the regular page that people were expecting to get. And then on top of that, I added a little bit of CSS. I put a custom logo in there. And then I added in some functionality that didn't exist anymore. And then I took out their branding, because I'm paying for it. You don't get to put your branding if I'm paying for it, right? And it's so cool because now that if you have literally any SaaS, you can just add your own code to it. It doesn't have to be a browser extension. It can be a worker that sits in between it. Migrating slowly. We see a lot of people do this type of stuff where they say, okay, we are going to be moving to React from whatever monolith that we had before, but we need to do so slowly. So what you can do is you can request the old site and then just incrementally replace the header or the footer or the sidebar or specific parts of your website with your new version without your old server having to have buy-in for that type of thing. You can sort of just replace it on the fly. We see that quite a bit as well. This one's a little bit silly, but I think it's pretty cool, is that alert, prompt, and confirm work on the server. You can, and this is really handy for writing CLI apps, where you can alert somebody, prompt somebody, and confirm somebody. And if you're writing a CLI app, it will just pause the input, allow you to type in things, press yes or no, and then return to you your actual data, as well as the console log with CSS coloring actually works in the CLI as well. You don't need to go get the node color package or whatever it is to do that type of stuff. Async local storage. This is a really cool Node API that Node came up with, and it's actually pretty interesting. So the way that it works, and the problem that async local storage solves, is that you can access and create a store inside of the context of a function, meaning that let's say you have a request coming in from your server, and that request needs to call 7 or 8 functions down the road. Generally, if you want data to be available to all of those call stack functions, you need to pass it from one to another, which generally, yes, that's what you should do. But sometimes you just need stuff to be available everywhere. And that's when you get into things like putting data on the request or having some sort of context object where you can put stuff. So async local storage will allow us to create a store. That's what that enter with is right there. And then any function that gets called down the call stack or down within the context will be able to reach out and get access to that store. Now, you certainly could do a lot of bad things with that, but it's really nice for storing session IDs and requests and country code or something like that for every specific request. So that's a really cool Node API that came out. And people said, hey, Deno, can we have this? And so Deno will polyfill all the Node APIs, which is great because you can just use the Node APIs inside of Deno. But they're also like, well, he says, I worry a lot about adding browser-incompatible APIs. Remember, it's a Node API. So what do? Well, we go to the standards bodies and say, we need something like this that will work in the browser and, of course, in all of these different JavaScript APIs. So now there is this stage 1 draft for this thing called async context. It will work very much the same way, and then it will be implemented, hopefully, in all of the other runtimes. Packages. So there's lots of packages out there, and that's kind of the whole idea behind this talk is that people are starting to write packages that don't just run in Node, but if you think about a lot of these APIs, okay, I'm going to use web streams instead of Node streams. I'm going to use the context API instead of async context API. So if you think about building your packages with APIs that are standard, then they will work everywhere. And we're starting to see, okay, well, like a big one for me was JS DOM. JS DOM doesn't work in a worker or in Deno or in Bun. However, people have written, there's this really nice package called LinkDOM, and they have a worker version of it, and it works in the browser. It works in a browser web worker. It works on Deno, it works on Cloudflare. It works everywhere, right? And that's really nice that you can do that. HTML rewriter. So Cloudflare invented this API called the HTML rewriter, and it's a really cool API. So this is not a standard, but everybody said that's actually pretty cool, so let's just do it ourselves. Let's implement that as well. And the way that it works is that you have a request coming in, much like I talked about the proxy version earlier, and you can write like basically query selector, jQuery-like matchers on your HTML and do little replacing. So whether that's as simple as saying, okay, well, we have the images on our application, but we don't want to serve them up from our whatever server we're paying for because that's expensive bandwidth. We want to put them on a CDN that's faster and cheaper to do that. So you could simply just intercept all those images and say any image that has a source where it's referencing /static, let's just on the fly replace it with the CDN URL that we have here. Or anywhere that I see a specific language, I could replace it. Or literally anything that is coming on in, you could replace classes. You could add dark mode to specific to things if you really wanted. There's a whole repo of worker tools. This is a really cool repo because they both have a bunch of different tools that make writing code across all of these platforms really smooth, as well as they have a whole compatibility chart of being like, where do these browser standards work at the moment? Because we're still trying to get them implemented across all of them. So check it on out if you are ever trying to implement something. Check out the worker tools repo because they have a lot of really good resources. File system. This is a bit of a weird one, is that there's no standard file system API. There's a Deno one, there's a Bun one, there's obviously the Node one. The funny thing about that is that the Node APIs work everywhere else, so the Node is kind of the standard. But there is a WGFS one, which is being looked at to possibly implement it. It's a little bit weird because like Cloudflare Workers doesn't have the concept of a file system. There's no file system. But if you are running code locally on your machine or doing like a build, then you will want that. There's so much more to this type of stuff. It's really not like a write once, work everywhere type of thing, at least not just yet. There's still certainly a lot of bumps, but that's the whole idea behind the Winter CG and all of things. It's a set of standardized APIs that allow us to create interchangeable building blocks, which is based on browser code, now runs on the server. So really what I want you to get out of this talk is when you go and build your next thing, your next worker, your next app, your next package, is build for standards as much as possible. You can polyfill them, you can get them to work, and then you'll be able to target for everywhere once you need to reach for one of these things. Thank you so much.